my era when I was secondary school, right? The trend is to wear baggy pants.
Yeah. Now
You know, I think it's coming back.
yeah.
Yeah, but I think a couple of years ago is to wear the slim pant jeans,
Yeah.
right? Must be like stick to the skin one.
Yeah.
If it was during my time, you wear stick to the jean, stick to the skin one. People will laugh at you. They'll at which thermal energy is lost from their bodies. So, explain why the layer of silver colored. So I add here, this one.
Yeah.
Explain why the layer of silver colored plastic strip reduce loss of thermal energy by conduction. Okay, so this one reduce loss of thermal energy by conduction. Now we got to recall what is required in conduction. How does thermal energy transmit through conduction?
The heat particles vibrate.
Yeah, they vibrate, and what must they do?
They transfer energy from one.
Yeah, so they have to be in contact, right? With
Yeah.
one. Okay, so we observe that inside here, are all the particles in contact with one another?
No.
No, right?
Yeah.
So there's actually small packets of what?
Or air.
So small pockets of air. Small pockets of air, which are poor conductor of heat. Okay, so they are poor conductor of heat, and because they are poor conductor of heat, they do not transmit the thermal energy.
Yeah.
Okay, so next one, how about convection? How does this thing prevent convection?
The fabric.
Yeah, because you must remember for convection to happen, what must the medium do? The medium must do something, right? Convection, the medium must move, right? Not? Okay, in this case, can the medium move?
No.
No, yeah. So no movement of medium to facilitate convection current. Right? So as a result of that, there is no convection current. So thermal energy cannot pass through convection. Are you okay?
Yeah.
Alright, then the next one, how come no radiation? So radiation,
silver colored.
very good. Silver, what does a silver color do?
It prevents radiation.
They are poor absorbers and emitter. Okay, poor absorber and poor emitter. So because they are poor absorber and emitter, they will not cause the heat to be transmitted. Right? So heat cannot be transmitted. That's it. So that's 4 marks for you. Next one. Okay. Okay, so when an aircraft is about to take off, accelerates on a runway from a rest rate of 3 meters per second square for 25 seconds. Average mass. Okay, so what do we have here? This is the acceleration.
Yeah.
Acceleration. Then the average mass. So we got a mass. So since we have acceleration, find the average accelerating force. What's the formula that we know of?
Mass. Force equals mass times distance.
Yeah. Huh? What distance?
Acceleration.
Acceleration. I have to go admit. So we have F, right? F is 1.2 times 10 to the power 5, and A is 3. So we multiply them together, we get 360,000 Newton, right? 0.000. Okay, find the speed after 25 seconds. Find the speed after 25 seconds. Now the acceleration says every 1 second the speed will increase by 3. So it happens for 25 seconds. Okay, so what we do is we take 3 times 25, 75 meters per second. This is the answer.
Okay.
Alright, next one, the minimum vertical force for takeoff. What is the minimum vertical force for takeoff? For it to take off, you gotta find the mass. So you see the mass is 1.2 times 10 to the power 5.
Yeah.
W equals mg. So it has to overcome this weight. So it's 1.2 times 10 to the power 5 times 10. Okay, so it's 1.2 times 10 to the power 6. Alright?
Yeah.
Newtons, alright? Okay, so that will give us another 4 marks. Next. Okay, next, electromagnetic wave have many applications. Here, so computer table state the region of the electromagnetic spectrum used for each of the application. Wow. Okay, mobile phone. What is the spectrum? Do you know this? To be honest, I don't know this.
I also don't know.
Microwave. Seriously, we gotta memorize this thing. Alright, so microwave. What's sunbed? Ultraviolet, UV. Sunbed, you know, those people who want to
Tanning
tan.
bed.
Yeah, they will sit inside this capsule bed, right? And then
Yeah.
they'll turn on the UV ray. Television remote, that's I know. Infrared. Satellite, microwave. Alright. So I guess you gotta memorize this. Which type of electromagnetic wave has the greatest frequency?
Let's see.
So Grandma X used Viagra in my room. So we have microwave, U and IR. M lah, right? Microwave.
Yeah.
Right, because the one on the right, this one is the greatest frequency.
Yeah, it's U.
What?
Isn't it?
Wrong. It's not microwave.
UV, right?
Yeah.
Yeah.
U. Right? The one on the left has the greater frequency, right?
Yeah.
Frequency. Yeah. Right, next. Well, that's 5 marks, eh? That's easy.
Wow.
This is killer, this one. Want you to die. If you never memorize, you're dead. See that? 5 marks, I really don't know. 4 marks of this stuff. Okay, but do you realize every year they ask about this stuff?
Yeah, every single year.
The grammar X use Viagra in my room.
Yeah.
I think every year have also, better memorize it, okay?
Yeah.
Yeah, go and memorize this thing. Alrighty, using my mouse. Okay, next. You know why I want to do this?
Why?
The mouse. I want to play game.
On your iPad.
Yeah, you know the Call of Duty.
Ah.
I shoot people. I can target like pew 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 pew. All of them will die, right? Instead of using my finger,
Yeah.
now I get mouse, advantage over all of them. But I gotta figure out how to configure it.
Yeah.
Yeah. Pew pew pew. Next. Okay, calculate the mass of liquid A in the U-tube. U-tube. Mass of liquid A. Okay, so how to find the mass? We have the density. So formula density equal mass over
Volume.
volume. Now to find the mass, take density times volume. So I got density, but do I have volume? U density 1.2.
No, you know the volume.
Okay, how to find the volume? A times H. Wait, what? Oh, they give you cross-sectional area. Cross-section area. So they have the height. So if you take cross-sectional area 3 times height, you get volume.
Oh.
Like a tube. Tube. So this is 3. This one is 15.
Okay.
Right? The area is 3. Right? So volume is 45. Now to find the mass, M equals to PV 1.2 times 45. So we get 54. Right? So the answer is 54 grams.
Okay.
Okay. So the pressure at point X due to liquid A. Pressure at point X. This is point X. So pressure equals to force over area. So I know the area is 3. But what is the force? It's 54 gram. So must convert to kilogram. 0.054 times 10. Here we are doing the W equal mg. Because you find the weight. The weight of this liquid is acting downwards. So using our calculator, we will get 0.18 Newton per cm square. So that would be the pressure. Okay, next. So the pressure due to liquid B at point Y is the same as the pressure due to liquid A at point X. Calculate the density of liquid B. Huh? What liquid B? Oh.
The shaded.
Yeah. Okay. Okay, the pressure due to liquid B, what? Is the same as the pressure due to liquid A at point X. Here is the same. So calculate the density. Wow. This one got me, this question. Pressure, find density. Okay, you're gonna use the other formula, the H rho G formula. You know the H rho G formula?
H rho G. Is it the
pressure, liquid pressure?
I think I know. Is
H rho G. So H is 24. Oh no. Okay, H, the height is 24 because it says 24 here. What is rho? Rho is the density. Alright, so it's 4 times rho times G. G is 10. Okay, so 0.18 equals to 24 times rho times 10. Rearrange using algebra. Rho is equal to 0.75. Right, so once again, formula saves the day. Right, H rho G. If you, I'm not so familiar with this because I haven't done a lot of this. I don't remember any HOG coming up the past few years, but there's one here, right?
This is what, 2015, right?
Yeah, 2015. Past 3 years don't have. I didn't see in 2018, 17, and 2016. Only 2015 so far. Okay. So formula, right? That with 8 marks of formula. Next. This guy asking for trouble. Why you cannot shoot upwards?
What?
Why shouldn't you fire an arrow vertically?
The arrow will fall back down.
Yeah, come down, hit yourself, no. Crazy one. Okay, same for weapon, you know. Next time you go army, right? Army, your SAR-21, you cannot shoot upwards, no.
But won't like the thing just fall down?
Yeah, it will fall down, but it will increase in velocity. If you are so sway, the bullet hit your head, right? You still gonna hit on it. It's still like a gunshot.
Wow.
So don't anyhow shoot upwards. You know, you watch the terrorist shows, right?
Yeah.
Terrorists always like when they're happy, what they do? They
Shoot upwards.
they're like, blah, 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 blah. That's a dangerous move. Okay, because the bullet can come down and hit you. So don't do that, okay? Next. Wow, look at this. 2,000 words to read. What's the question? Work done in pulling back the string. Formula, what's the formula for work done?
Work done equals
Force
force.
by distance.
Yeah.
Okay, let's find. Alright, so we get keyword here. Force 125. What's the distance he pulled back? 60 cm. Right, so first one is just 125 times. We cannot use 60, you gotta change to meter, so 0.6. Just remember everything changed to SI unit. Right, so that gives us 75 joules. Okay, so work done 75. Didn't even read the question, you can do one question. Right, the speed with which the arrow leaves the bow. Wow. How to find speed?
Speed, distance over time.
No, cannot.
But you don't have the time.
Must use kinetic energy. Half
E
mv squared.
square.
Alright? Because v is the speed, so this is the energy. Now, so we read that the energy transferred to the arrow is 75%. It's 75%. So we gotta find 75% of this. Right? So what they're saying is that this guy pulled 75 joules, right? The energy, his armor, 75 joule, but only 75% is transferred to the arrow. Did you get that?
Wait, repeat again.
The pulling force,
Yeah.
by the guy is 75 joules.
Yeah.
Only 75% is transferred to the arrow. Some of the energy is lost. Right? So that's why they say only 75% of the energy transferred to the arrow when the string is released is only 75%. So we gotta find the 75% first.
75% of 75 joules, is it?
Yeah, correct.
Oh, okay.
So where's my calculator? Calculator. Wait. Okay, so 75% of 75 joules times 75, we get 56.25. So 56.25 joules is converted to the arrow, which will give us this 56.25, right? Is our half mv squared. That's kinetic energy, right?
Yeah.
So the mass is 0.18. So we work backwards. 56.25 equals to half times 0.18 times v squared. So work backwards again, we get v is 25. Right? The maximum height reached by the arrow. So in this case, kinetic energy will change to gravitational potential energy. Right? Because this thing will fly upwards, huh?
Yeah.
Fly upward. Okay, so KE convert to GPE.
Yeah.
Right? So what is the maximum height? So my K is 6.25. It will be equal to mgh. Correct? So
Yeah.
6.25 equals to 0.18 times 10 times h. H is unknown, so h equal to 31.25 meter. Right? So okay? Is this okay?
Yeah.
Okay, next. How many marks? Another 7 marks. Okay, cyclist applies a vertical force of 110 on the pedal of a bicycle as shown. Calculate the moment about the pivot. Moment. Okay, moment. What's formula for moment?
Force
Yeah.
times
Times
distance.
perpendicular distance. So the force is 110. Perpendicular distance is 5. So answer is 550 Newton centimeter.
Oh.
Easy or not?
Yeah.
Super easy, right? Oh lord. This is formula. If you don't know formula, you die.
Yeah.
Right. Next, the pedal moves from A to B. Okay. Why the force applied at A will have a different effect from the force applied at B? So force at A it's 5. Then B. Where's B?
The side.
Here. Here come to here.
What's the question?
How come the force, even though she applied 110 Newton, right? Here she step 110 Newton, here also step 110 Newton. How come the moments are different at this point and this point? Moment equals to what? F
Times distance.
B. Now what is the perpendicular distance at point A?
Unknown.
0.
Why?
Because it's directly above pivot.
Okay.
0 centimeter. But how about over here at B? Is certain, maybe 10 cm, I don't know. Right? So the moment at A is 0. NA equal to 0. NB equals to 0 times 10. Right? Which is 1100 NCM. Okay? So to answer the question, why the force applied is different is because the perpendicular distance to pivot at point A is 0. Hence, moment is 0. Right? Whereas at point B, it is a certain value. Right? Hence, moment is not 0. Right? So that's the reasoning. Do you understand this one?
Yeah.
Yeah, it's about the perpendicular distance, right?
Yeah.
Don't the perpendicular distance is not this one. It's not this one. Red color one, right? It's not. Right? It is the perpendicular distance, 90 degrees.
Okay.
Alright, next. 5 marks. Let's go. Why light is reflected inside each prism?
Why light reflected inside each prism? Objective prism.
Why light? Okay, so you see that the critical angle is 42. Angle of incidence it's 45.
Yeah.
So the angle of incidence angle of incidence
Yeah.
is greater than critical angle. Hence, there is total internal reflection. Right, the angle of incidence, where's the angle of incidence? Here. This one is 45. Critical angle is 42. So the angle of incidence is more than the critical angle. You get total internal reflection.
When the angle of incidence is greater than the angle,
The critical angle.
you get total internal reflection.
Yeah, here.
Okay.
Total internal reflection. Right? So that's the reason. Um, so what's the other reason? You can say the light. What is the property of light? Angle. The law of reflection, right, says the angle of incidence always equal to angle of reflection. Okay, there's one property of light. So that's why here will be 45 degrees. Right, both sides 45. So complete the ray shows its path through the periscope. Okay, so this one, there's one more line coming here. You hit this thing, go down, and then go this way. Right?
Yeah.
So draw the appearance of object O as seen through the periscope. It will be upright. Object O will be like this. Okay? Is that alright? Because you see this tip, if you follow this tip,
Yeah.
it ends up here, right?
Yeah.
So arrow out.
Oh. Okay.
This one, that's very simple.
Yeah.
Alright, so calculate the current in the battery. Current. Okay, so total effective resistance is 0.7 Look, right? So a car of mass 950 kilogram has a speed of 20, accelerate uniform rate for 6 seconds, the car travel constant speed, final car is about to rest. So show how the speed varies with time for the whole journey. Okay, so here we are supposed to draw, right? Gotta draw the whole thing.
Yeah.
The whole story over here. So let's start with the beginning. Okay, what's the beginning of the story? Oh, yeah. Okay, at the beginning, what happened? Has a speed of 20 at time 0. So at time 0, it already started off at 20. That means it starts from here.
Yeah.
Alright? Oh, shit. It starts from here. Okay? For accelerate at a uniform rate of 3 for 6 seconds. So we're going to start from here. Accelerate at 3 for 6 seconds. That means from here to 6 seconds. Now it accelerates at 6. At 3 meters per second squared. So how does it look like? So because the acceleration is 3.
Yeah.
The acceleration is 3. That means the gradient is 3. That means that every 1 second it must increase by 3.
3.
Alright, do you know what I'm talking about?
Yeah.
Every 1 second it has to increase by 3. So now in 6 seconds, how much would it be? 1 second will be 23, right? 2 seconds is 26. So at second number 6, what will it be? It is 29. Because 1 second increased by 3, 6 seconds must increase by 18. So it should be at 38. Right, so we're going to find 38. Right, so 38 is like somewhere here. 38, 6 seconds. Okay, so we're going to draw a straight line. It's a straight line from here to here. Right? Can you see how I work it out? Hello?
Yeah.
Yeah, can you see how I work it out, this one?
Yeah.
Can. Okay, next. So next is it accelerates at a uniform rate for 6 seconds. Then the car travels a constant speed for 4 seconds. So constant speed, so it's 6 to 10. Until 10. Constant speed. Oh. Constant speed from here to here. We always jump. This is the last. There, why like that? Okay, freehand. Okay, so this thing goes here. Okay, next 4 seconds. Then the car is brought to rest in a further 5 seconds. 5 seconds means it's from 10 to 15. Right, brought to rest means it goes to 0. So from here, go to 0. Okay? Is it visible? Can, right?
Yeah.
Can see, yeah? So this is the graph. So find the distance between T0 and T6. So we need to find the distance. Now the distance would be the area. Is that right? Find the area. So what's the area of the rectangle? It's 20 times 6, right? So here is 120. Okay. Then the triangle. The triangle is 6 times 18 divided by 2. 6 times 18 divided by 2, here is 54. So you add them together, you get 120 plus 54, 174. Answer 174. Right. Next.
Yeah.
So far so good. So calculate the resultant braking force as is brought to rest. Resultant braking force. What is the resultant braking force? Now, what formulas do you have that connects force and whatever we have over here? We need to find the resultant braking force. So braking force, braking occurs at this part, right? And the formula that we learned for braking or force and acceleration is F equal ma. Now we want to find the resultant braking force, means we want to find F. That means here F equal ma. What I need is the mass of the car. So the mass is 950 kilogram times the acceleration. Now you look at this this part, right? This part, is there acceleration here? The blue color thing.
No.
Yeah, it's actually deceleration. So
Yeah.
deceleration is negative acceleration. So I need to find what is the negative acceleration here. What is the deceleration? So once again, this is a speed time graph. Speed time graph, the gradient is the deceleration. So find the gradient, right? So this is 5, and vertical is 38. So how to find the gradient? Rise over run.
Rise over run.
Yeah, so it's 38 divided by 5. So it's a negative value because it's downward sloping. So it's 950 times 7.6. Right, so using calculator we get 7220 Newton. Alright, so formula. Alright, this one is formula. Kinematics by using formula. Okay?
Yeah.
Alright, so go on to the next one. So that is 6 marks. 7 marks, I think. Okay, this is a white water cooler called calculate the mass of water pumped per minute into the lake. Where's the lake? Through the course into a reservoir. Okay, so actually water flows like here, 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 then go up again.
Yeah.
Right, go up here. So now find the mass of water pumped into the per minute into the lake. Okay, so to find the mass, I have density, I have volume. So density equals to mass over volume. So I want to find the mass. Density times volume. So density is 1000 times volume. 780 meter cube.
The cube.
780. So the mass is 780,000 kilogram.
Yeah.
Right. So the weight of water, yeah. So W equal mg, right. So we take 780,000 times 10. Okay.
Yeah.
So it's done 7.8 times 10 to the power 6 Newton. Next one, the total work done per minute by all 5 pumps. So formula work done equals to force times distance. Because it needs to move this weight 7.8 times 10 to the power 6 up a distance of 5.5 meters, because can you see that this 5.5?
Yeah.
So that's the only distance. All the 5 pumps.
Hello?
Yeah, so you multiply, we get 4.29 times 10 to the power 7. Alright, so it's about 4.3 times 10 to the power 7.
Do you leave it? You have to leave it in standard.
Yeah, because it's too big, the number.
So you can't just write up the number.
Yeah, it's too big, number too big.
But if you write out the number, you won't get penalized.
It's okay.
Okay.
Why? Because they didn't specify standard form.
Okay.
Yeah, but it's just very big. Number is
Yeah.
very big. Okay, average output power of each pump. Power equal work done over time. Oh, wait a minute. The previous one got a times 5. Right? Because they want all 5 pumps.
Okay.
Right? Just times 5. So really big number.
Yeah.
So average power, formula for power.
Power equals work done over time.
Yeah, so the work done is the 4.3 times 10 to the power 7 over time. 1 minute, so it's 60 seconds. 715,000 watts. Okay?
Yep.
Wait. This one no need to times 5. Because this is already 5. Your 780 is 5.
Oh,
Right?
they said
Yeah, they already say it's 5.
Okay.
So this one is correct. It's just one time. And instead, the average power of each pump, you're going to take this and divide by 5. Because this is the total power. So power each pump 143,000 watts. Okay? The number bottom must divide. Next. Looks a bit difficult. 14. Slightly
Yeah.
different. So many words.
Yeah.
Calculate the force that is exerted by the rod to cause a pressure of 7200 on the paper. Okay, so pressure equal force over area. I'm just looking at keywords. P equal F over A. So I need to find F. F equal PA. So F equals to 7200 times, what's the area? 0.025. Right, so you multiply that, we get 180 Newton. Right? So just try to remember the formula. It's easier to do. So the force applied at the end of the handle to exert the pressure. Okay, so the force required is 180. So this part coming down, right, it needs to be 180 Newton.
Yeah.
So 180 Newton is exerted by this force. But because there's a distance here, there's movement, so he doesn't need to exert 180 Newton, right? So the anti-clockwise moment, let me see here. Okay, so the upward moment is 180. So the question is, what is this downward? downward. Okay. I need to exert. Wait. The force is 180 Newton, but what is the anti-clockwise moment? The anti-clockwise moment you gotta take 180 times 10. So 180 times 10 equals to 1800.
Yeah.
Newton cm, right? Then on the other side, this one is, it should be 1800 equals to F times 30. So F is equal to 60. So the force here is 60. That's it. Just 60. 60 Newton. Okay? Yeah, just 60 Newton there. Yeah. Next one. What's the next one? Okay, next one is this. Red light is incident. Okay, this is light. This one a bit more boring, right? 2014. Not so exciting. Too many questions.
Yeah.
Very tedious. I
Yeah.
don't want to fall asleep. So many things to read. Okay, complete the ray diagram to show the path of the red light beyond P. Draw an arrow to show the direction. Alright, when it's going out, where will it go? It will go towards the...
Normal.
No, go away.
Away.
Away. So, okay, this is 48, this one is 42. So it will go away from normal. Should go here. Right? Should go away. So this angle is bigger. Bigger than 42. More than 42. Right? Next. Yeah. 48. So calculate the refractive index of the glass of the prism for red light. Okay. I think do you need to measure? You need to measure. No need to measure.
Oh.
So find the critical angle. Sorry, find the refractive index. Oh, okay. The clue is this. The red light is incident at point P on phase at the critical. Okay, so this one is wrong. Sorry, I didn't read this thing. They say this is a critical angle. Now, critical angle means that this is 42, and the light ray will reflect this way. Okay, it doesn't come out. It will go parallel to the surface or perpendicular to the normal. Alright, this is when it is at the critical angle. Okay?
What?
At critical angle. So there is always like more than. Now remember, more than critical angle, we will have total internal reflection. Equal to critical angle, it will be perpendicular to normal.
Okay.
So that's why this light ray, it doesn't go up. Right? It goes perpendicular to the normal.
Okay.
Okay, so to calculate the refractive index, you must use the formula sin
I over 10 R.
C equal to 1 over n. Or n equal 1 over sin C. So sin 42 equals 1 over n. n equals to 1.494. It's about 1.5. Right, so the refractive index is 1.5. Okay, here you use we're using the formula. N equal 1 over sine C. Can?
Yeah.
Alright. Very tedious. When I take a drink.
Okay.
Take water. Wow. Okay, next. Okay, we have a string on a guitar. It's plugged. Okay, then the pedal plug one more time. Same string but louder pitch. Now, same string, louder pitch means the amplitude is higher, but the frequency is the same. So maybe we can choose a certain magnitude. How much? Five here, right? 5 here. Okay, so we draw the thing. Gonna go up. Here. Go up.
Why you choose?
Just make sure it's higher. The amplitude higher can already.
So it can be anywhere.
Yeah, just higher, but frequency same.
Okay.
Okay, now he tighten and plug again. Tighten plug again means higher frequency. Right, so there'll be higher frequency. Hence, there are more waves than previous. Right, there are more waves than previous. The period will decrease. Period decreases. Is it okay?
Yeah.
More waves. So the higher frequency means there's now more waves in the same period of time. Right? So this part you don't have to draw, is fine. Do you understand? Yeah?
Yeah.
Because he tightened the thing. Do you play guitar?
Not really.
Huh? No more?
No, I know like a few chords.
What? Oh, you know a few chords. So you play a bit.
Sort of.
Okay, next. A large thundercloud becomes charged with a negative charge at the base. So we get lightning. Calculate the quantity of charge that's transferred. So Q equal what?
IT.
IT. So 11,000 times 0.00011. 1.21. Right, so we get 1.21 Coulomb. 2 marks. Okay, so the question is, when this cloud passes by, what happens to all, this copper plate? It's negative.
What?
Over here, the copper strip, right, got negative charge. Alright, so this giant cloud comes by. What's going to happen to the negative charge? Attract or repel?
it's gonna
repel because they're same. So all these negative
cloud is also negative, is it? It's also negative, is it?
Yeah, so they will repel lah. So all the negative
Okay.
stuff will go underground, right? They just explain what happens to the negative charge in the copper, right? They will be pushed downwards because of repulsion.
Okay.
Yeah, so they will go underground, right?
Okay.
Why so boring, this one?
Yeah.
The one like more interesting. Is it too many calculations? Oh man. Okay, let's see how many more. 7. Or is it the afternoon? 9. Not so many. No choice one. Oh, yeah, the choice are here. Like a lot of questions. Do non-stop.
Yeah.
Okay. 7. Never mind. Good practice. Okay. 7. After this, must take a short break again. Okay. Question number 7. Let's take a look. So a circuit contains a battery. I think you've done this before. Show the reading ammeter A2 and A3. A1 is 2. Here is 2 milliampere. The reading, complete the table. A1 is 2. Split. So A3 is 2. Okay, so since this is double, so this must be 1. Here is 1 ampere. And okay, so A2 will show 1. And then A3 is 3.0, right? Do you know why?
Can you explain?
Yeah, let me explain. Okay, so where is the higher resistance?
Sorry?
Here is higher resistance, right?
Oh yeah.
The left side has more resistance, correct? So the right side, we have a current of 2. So 2 milliampere passes through that part. And because electricity will always flow through the path with less resistance, right? Electricity will go to less resistance. That means more will go to the right side. More here, more will come here. Now, how much more? It's exactly 2 times more, because here it's this one. This one is 2. This one is 4. Right? So more electron will flow through here. Exactly how much more? 2 times more. Now, if 2 times is 2, here means that 1 time will be 1. Okay, so 1 will pass through and 2 will pass through here. Why? Because the resistance here is twice of this.
What?
The resistance here
is
twice.
There is okay.
This one is twice, 4,000. This one is only 2,000. Right, so what this means is eventually, here is 2 milliampere, here is 1 milliampere, they will come together. So when at this point, they join together, this will be 3 milliampere, because 2 plus 1 equals 3.
Okay.
Right, so that's why we have these numbers.
Alright.
Okay, next is calculate the potential difference across the battery. So how to find potential difference? That means how to find voltage. How many volt? To find voltage, right? Just take V equal IR.
V
equal IR. So this is 1 and this is 4,000. Oops. V equal IR. So 1 milliamp times 4,000. 1 milli is 0.001. So we take 0.001 times 4,000. It's the same as divide by 1,000. So the answer becomes 4. Alright, so here is 4 volt. Now, so according to the parallel formula, V equal V1 equal V2. So here also 4 volt. So here also equal to 4 volt. Is it okay? So across the battery is 4 volt. PD across the battery is 4 volts. Are we okay with this?
No, can you please?
Yes, let me repeat one more time.
Yeah.
Alright, let's start from the beginning. Okay, so the question here is calculate the potential difference across the battery. So where is the battery? Here, right?
Yeah.
V. Formula V equals to IR. Formula is V equals to IR. That means I take current times resistance. Now, but I don't have any current, I don't have any resistance here. Okay? But I know one thing. What I know is that V equal V1 equal V2 equal V3. What does this mean? This means for me to find the voltage, all I have to do is to look at here. Because they'll be equal. The voltage is equal. Because it's parallel, right? So now the question is, how do I find the voltage here? How to find the voltage here? So formula V equal IR, right?
Yeah.
Let's find the voltage here. Now the voltage is 1 milliampere times 4,000.
You have to convert the milli.
Yeah, you gotta convert to ampere. So 1 milliampere is equal to 0.001 ampere. Right, so to find V, take 0.001 times 4,000. Because the R is 4,000.
Yeah.
So 0.0, so we get 4. So this is 4 volt. Now since this is 4 volt, here also 4 volt.
Yeah.
So the answer is
4.
4 volt. Oh, I only 2 marks. Very tedious. Calculate the energy transfer in 5 minutes in the 2000 ohm resistor. So energy EPT, energy equal power times time, right? E equals to P times T. Okay, but do you have power?
No.
No, but we know the formula for power.
Yeah.
EIV, right?
Yeah.
So 2 MA times 2000. IV, current. No, sorry, wrong. The V is 4, right? 4 volt. P equal IV. So we get 0.002 times 4, 0.008. Right? Watts. That means the power here is 8 watts. 0.008 watts. So to find the energy, 0.008 times 5 times 60. 2.4 joules. Okay, so we get 2.4 joules for this one.
Wow.
Right?
This question is so tedious.
Yeah, electricity. Yeah. Oh, I just want to sleep. I think it's the I bought this this juice makes me
What
sleepy,
juice?
man. Sparkling vitamin C.
Sparkling vitamin C.
Yeah, the offer $1 only.
Ah.
Yeah, I always buy the offer stuff. So there's a $1 sparkling vitamin C grape juice, and then there's another Just Cool sparkling citrus blue juice. All these juices are making me dizzy. Wait. Wait, I think you can see. Can you see?
Ah.
Can you see the screen?
What does it taste like?
I don't know. I haven't opened this. I bought this. Drank this. This one made me feel sleepy, you know. Very sleepy juice.
But is it nice?
It's a lot of sugar.
Nice.
Plenty of it.
It should make you feel awake, what?
No, I feel sleepy. Okay, okay, so we come back. Okay, let's go. Can you see the whiteboard again?
Yeah.
Okay. Or maybe the question seemed more tedious.
Yeah, it does.
For 2014. Are there more questions? Seems like more questions.
Yeah.
We've been doing for 1 hour already, you know. Haven't even reached the other section yet. Oh man. Okay, next question 8. Okay, let's go. Let's finish, then we take a break. Right?
Yeah.
The resistance of filament changes during the first 1 second. Suggest why the resistance of the lamp changes. What? So the R change. They're asking why the resistance will change. At first, resistance here, then resistance went up.
Yeah.
Okay, it's because the heat caused the wire to expand. Longer, right? Longer means more resistance.
Yeah.
Okay?
Longer and thicker, right? Means more.
No, longer and narrow. Long and narrow. But this case, it became longer.
Okay.
Longer, so more resistance. Next, a fuse is used in the circuit. Why the fuse is more likely to melt when it's first switched on than when it has been lit for 5 minutes. Okay, so more likely to melt at first because the resistance is lower. This is a difficult question. Right, so the resistance is lower at first, hence smaller current can break or can melt the fuse. Right, that's about it. Wow, still got 2 more, 10 questions. Next. Describe how thermal energy is transferred from the liquid to the surrounding. Okay, so liquid here, liquid to surrounding. Liquid to surrounding. Alright, so it's 75 degrees Celsius. Both 75, right? So it should be radiation. Okay? Heat is given off through radiation.
Okay.
Right. Sketch the relation with time of the temperature it can be. Okay, so in this situation, which one will cool down faster? Is it the can A or can B?
Can
Which one emit faster?
emit faster is can be.
Yeah, can be because it's dull and black.
Yeah.
So, okay, the dotted line is can A. So, can B will be faster. That means we gotta draw it faster lah. So that means it goes down here, and then go here, and then go here, right? As long as it's faster.
Yeah.
Because blue color will emit faster. Okay. Alright, done. Two. Wow, same thing. Two forces, blah blah blah. Forces. Okay, draw. Draw means you gotta draw the rectangle thing again. Okay. 6 Newton. 12 Newton at right angle. So 12 Newton right angle means it's here, this direction.
Yeah.
Double. So this is double the length.
Yeah.
12 Newton. Now what is the resultant force?
Is diagonal.
Yeah. So we draw triangle. Then you gotta measure. Okay. Use a ruler. Measure green color. Right. Measure green color distance. And you will find that you determine right?
Yeah.
Is about 6.7 cm times 2. So it's
Why times 2?
Because the scale is 2 times. You will notice that this is 3 centimeter. So 3
also you
centimeter.
have to deduce it yourself lah.
You gotta use the brain. They try to shoot you, but you gotta figure out, right?
Okay.
Okay, the scale. Wow, finally section B.
Yeah.
Why so long?
I don't know. Usually all like question 9 or question 10 is section B already.
Yeah, I think the format is longer last time.
Yeah, I think so too.
Suffer. The past suffer. 2014.
Yeah.
Okay, state the speed of ultraviolet waves in a vacuum. Okay, we're gonna finish this, right? So state the speed 3 times 10 to the power 8 meter per second. So this is fixed. Calculate the frequency of wavelength 10 nanometer. So V equal F lambda. F equal V over lambda. What is the V? So it's 3 times 10 to the power 8 divided by 10 times 10 to the power minus 9. Okay, this is nano, so it's 10 times 10 to the power minus 9. Alright, so here just key in calculator, you will get 3 times 10 to the power 16. Is this alright? Take a look.
Yeah.
Awesome. You state the order of magnitude. What?
Calculate. Yeah.
Okay, I'm clueless. I don't know what this is.
What's the answer say?
The answer says the order of magnitude is 10 to the power minus 10.
The order of magnitude.
Yeah. I have no idea what it is. Okay. Skip.
Yeah.
Don't want to do.
And this is a choice, right?
Yeah, I can choose.
Yeah.
Oh, this is easy lah. Radio wave, microwave, you state one use of each. See, it's the same stuff again. Radio, what's the purpose of radio?
Satellite.
No, radio. Radio lah, and TV. Microwave?
Satellite.
Satellite. Infrared?
The UV. Oh, okay.
Oh, no, don't have UV. That's all.
Yeah.
Okay, that's one question, no?
Yeah.
Huh? Oh, so their section B is very short.
Huh?
That's all. That is one question. Choose two. So in the past, the section B, right, the choose two question one, right,
Huh?
it's very short. That's why the front part so long.
Oh, okay.
That's one question. That's all.
Huh.
Right? So we look at the next one. So we see this stuff we don't like to do, right? Do you like to do?
No.
We hate magnetic field. Go. Next. What's this? Oh, this is easy.
What's that?
What's the function of earth wire? Don't care. What's the function of
Oh.
earth wire? Earth wire. Earth wire.
Function of earth wire is to.
First, you must name PQR. P is life.
Yeah.
Q is Q is neutral. Then R is earth. Okay, why? Because R is connected to the metal casing. Anything that's connected to metal casing is the earth. Right? Anything connected to fuse is the life. So this must be neutral. Okay?
Yeah.
Okay, so what's the function of the earth wire? So in case of current leakage, the extra current will be directed to earth, right? Then whoever touch it will not get short circuit, will not get shock. Okay, that's the purpose of the earth wire.
So it's only if there's a surge in current.
Yeah.
Okay.
Okay, next. Alrighty, next one. What's this? Oh, format. What's this? The user wish to connect a 2 kilowatt heater in parallel with a tree. Discuss whether this will be a sensible idea. 2 with 3. Oh man, it's actually quite tough. Okay, so we need to look at the story. So the original story is that the current is 15. I mean the fuse, right? Fuse is 15 ampere. 15 ampere means that anything more than 15 will cause the fuse to blow, correct?
Yeah.
So now we are here and we have 2 heaters and they're connected in parallel. So we want to calculate the total resistances, right? So 1 over RT equals to 1 over 3,000. Okay, no need. What is the current here right now? I equal to P over V. So the power is 2,000, right?
Yeah.
The voltage is 240, right? So this is 8.3 ampere, right? So the current here is 8.3 ampere. How about here? I equals to 3,000 divided by 240. So this becomes 12.58. So the current here is 12.5.
Yeah.
Now these two are connected in parallel, correct?
Yeah.
So parallel means the total current I equals to I1 plus I2, right? So it's 8.3 plus 12.5. We get a value of 20.8. Okay, so this one is more than this. See that the field is only 15.
Yeah.
But when you put 2 heater, the current is 20.
20.
Yeah, so that means we shouldn't put 2 heaters because it exceeds the safety limit of the fuse.
Okay.
Right, so it will blow, die while taking a shower. Okay. Just kidding. Okay, next, the element is made of metal. Use kinetic to describe the effect of atoms as alamak. It's so easy, huh? Temperature rise. The particles will gain heat, right?
Yeah.
Then they will vibrate faster, right?
Yeah.
Because the heat energy convert to kinetic energy.
Yeah.
Right? So describe the effect on the atoms. So basically, they will gain heat, vibrate faster, gain kinetic energy, move, vibrate further apart, and the metal will expand.
Okay.
That's it. Okay, now we know why the front is so lengthy.
So long.
Because back side is so short.
Yeah.
Okay, time for another short break. Right,
Okay.
it's 3 o'clock. What time? You have to go take a nap or something or rest? You seem like you still have flu. Huh? You still got flu, right?
Yeah.
Time you want to come back? Up to you. I'm okay. Anytime.
Anytime. Anytime.
You what time you want to come back? 4?
Yeah, okay.
4 o'clock, right?
Yeah.
So we come back 4 o'clock, go and play a few rounds of game.
Okay.
Shoot some enemy first. Okay, see you later. Goodbye. 2013, let's go. Alright. So parachutist jumps from a high altitude balloon. See the initial acceleration of the parachutist. Initial acceleration. So he's jumping out of the thing. Immediately after jump out, right? The acceleration. Remember the acceleration due to gravity is a value of 10. Is it okay? So it's always a value of 10. Is that okay?
Acceleration due to gravity is always 10, is it?
Yeah, it's just 10.
Okay.
Okay, next. Name 2 forces acting on the parachutist that oppose each other as she falls. So first one, we have the gravity, right? Gravitational force. Right? Oh, so small. Yeah. Big one. Gravitational force, the other is air resistance.
You're typing.
Yep. Bluetooth, huh? Bluetooth everything now. Yep. Everything Bluetooth. Okay? So there's gravitational force and air resistance. Next, so as the parachutist falls, her speed changes as shown. Acceleration decrease between A to B, so just why this happens. So between A to B, can you see that this thing is like going downwards?
Yeah.
So the gradient has decreased. So suggest why this happens. Why is the acceleration decreasing? Is because the air resistance. Oops. Okay. Air resistance increases with the increasing speed of the parachutist. Okay, so the air resistance increases. This reduces the resultant force acting on her, causing to decrease. Right? So basically, it's the air resistance increasing. Is that okay?
Yeah.
air resistance going up. So far okay. There's 1, 2, 4 marks here. Let's go. Okay, why the speed is constant between B and C? So between B and C here is constant, this part, B and C. So the question is, why is the speed constant? Alright, now there's this thing called terminal velocity. Right? Or we can simply say that the speed is constant because the air resistance increases to a value that is equal to gravity. Alright, so basically the up and the down is the same, hence there is a zero resultant force, and hence the speed remains constant. Okay, this idea is okay. Are you okay with this idea? Zero resultant force, because the up and the down is the same. At this part,
Yeah.
the air resistance is pushing the person up. The gravity is pulling the person down. The forces are the same. That causes the resultant force to be zero. Zero resultant force. As a result of zero resultant force, the speed remains the same.
Okay.
Right. At which point was the parachute open? It's open at C. C is, let's take a look. C is here, right? Why? Because after open, right, what happened to the speed? Decrease.
Decrease,
okay? Yeah, makes sense. So, yeah, that's it. So the sound from a musical instrument travels through air as a longitudinal wave. What is meant by a longitudinal wave? Okay. So, a wave that travels in a direction parallel to the direction of vibration. Alright, so this is just the definition, okay?
Wave that travels in
the direction parallel direction of vibration. Longitudinal. Looks like this. This is a longitudinal wave. Because the direction of vibration is here. Forward, backward. Right, compression and rarefaction, and it's moving like that. Okay. Okay. What's the frequency of the wave? So we need to find out what is the time for one wave. What's the period? Period T. Where is one wave? One wave is from if it is here, this is one wave. Right, so period T is 0.01. Now what's the formula for frequency?
Frequency is F equals 1 over T.
Yeah, so 1 over T equals to 1, 0.01. We get 100. Okay, so formula is 100 Hertz. Do you know why this is one wave?
Yeah.
Yeah, huh?
Yeah.
Right. So it's 100 Hertz. Next. A mechanical digger is used to remove soil. The bucket, blah, 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 calculate the mass. So density equals to, what's the formula? Density equal to mass over volume, right? So we want to find the mass. So m is equals to dV, which is equals to 2400 times 1.5, right? So we get 3600 kilogram. Right? Formula for density. Next.
Yeah.
Find its weight. So formula W equals to mg. So it's 3600 times 10. That will give us 36,000 Newton. Right? Next.
Yeah.
So far so good, right? So the center of gravity of the soil is a horizontal distance 2.5 meter from the front edge. Moment. What's the formula for moment? Force times perpendicular distance. So find the moment about y of the weight of the soil. Okay, so this thing 36,000 Newton, and the distance is 2.5 meter. So we take 36,000 times 2.5 meter. Right, we get 90,000 Newton meter. Is it okay?
Mm-hmm.
Yeah. So far okay. That's question number 3. Oh, I haven't finished.
The digger does not.
Okay, so the digger does not tip over. Why the digger does not tip?
Because it
How come when they raise... Huh? What?
it has a broad base.
Hmm?
Is it because it has a broad base?
Yeah. But the idea is that even with the... Okay, as long as the center of gravity is within this base,
Mm-hmm.
it will not tip over, right? So even with the bucket of soil,
Mm-hmm.
the center of gravity maybe it's like somewhere here.
Yeah.
So it's still within this base, right?
Yeah.
So once it's within the base, it will not tip over. Okay? Within the base, it will not tip over. So that's the reason. Okay, next. The center of gravity of the soil is raised through a vertical distance 2.1. Find the work done. Formula work done equals to force times distance. So the whole thing, how heavy is the whole thing? 36,000 Newton. So we take 36,000 times 2.1, right? So what's the work done? 75,600 joules.
Yeah.
Alright, so far is it okay?
Yeah.
I think it's pretty okay, this one.
Yeah.
Hmm?
It's pretty alright.
Yeah, all using formula so far. So we go to the next one. Alright, state the speed of ultraviolet wave in vacuum.
3 times 10 to the power of 8.
Awesome, that's correct. 3 times 10 to the power of 8 meter per second. The frequency V equal F lambda, F equal V over lambda. So V is 3 times 10 to the power of 8, lambda 2 times 10 to the power minus 8. We get 1.5 times 10 to the power 16. Right, this looks familiar. Name one region that contains waves with a higher frequency than ultraviolet waves. Grandma X
uses
Viagra in my room. Grandma X.
Mac.
Oops, sorry. Gram.
X-ray.
What?
X.
Yeah, X-ray. X-ray is fine. So what's supposed to X-ray?
To scan
A body, right? Look inside, see whether you broke your ribs or not. When you fall down from the skateboard, right? Your leg. Have you ever broken your leg before?
No.
Really? Yeah. I thought people who play skateboard always fall down.
I've never broken any bone in my hand.
You fell down,
Yeah.
Yeah. Would you recommend a booster board?
Yeah. It's very convenient.
Okay, but I think I better not. Already. Next time. Alright. Why the temperature recorded by sensor B changes very little? What is this? Every time I see words, it's like, oh man. Read. What's going on? So yeah, sensor A, sensor B, electric supply. Oh, you see they put the heater here.
Yeah.
They put the heater here. That means only the top part is hot. Alright, because hot water will not sink to the bottom. So how come sensor B, why temperature, why the sensor here doesn't increase in temperature? Why? Now it doesn't increase in temperature because the reason for that is because the heat, hot water doesn't travel down.
Okay.
Do you understand why?
Because the heater is on top.
Yeah. Will hot water ever travel down?
Nope.
Why? Because hot water will always remain at the top. It rises. Get it? Hot water rises.
Yeah.
It's not going to go to the bottom. Okay, next. So, I'm going to explain this. Okay, no need lah. Let me explain. Where the heater should be placed so that both record approximately the same change. So you want to have the same change. This particular heater got to be at the bottom. Alright. So when it's at the bottom, you will create a convection current. Because the hot water will rise.
Yeah.
Right? Then you get a convection current. Cold water will come down. Alright. Okay, so when the wheelchair is accelerating along a horizontal road, what energy is converted by the motor into useful what energy? So it's an electrical wheelchair, correct? Electrical, what does it mean?
It is powered.
So the chemical potential in the battery, right, is converted to electrical energy. Calculate the maximum horizontal distance the wheelchair can travel at maximum speed. Okay, so the info is here. Speed is 1.5 meter per second. The time taken is 2.8 hours. So you want to find the distance, DST triangle, right? So D equals to S times T, which is 1.5 times 2.8 times 60 times 60. Okay? So when you multiply that, you get 15120 meters. That's the answer. Calculate the input power to the motor for the wheelchair traveling at maximum speed. So power equals to?
Done over time.
Yeah, but another one is
PIV.
EPTIVIR. Right?
Yeah.
So PIV, so I must find voltage and current. Voltage, current. So it's 24 times 6. Alright, so calculate the amount of energy charge passing through the motor and the wheelchair travels for 15 minutes. Formula for charge. So the current is 6. $15. Is that right? Next.
Yeah.
Okay, the total mass of the wheelchair and the passenger is 160. The wheelchair accelerates. Force needed to cause this acceleration. Formula, please.
Force equals MA.
Yeah. M is
16.
60.
Oh, yeah.
What's the acceleration?
1.5 meters per second.
That's the speed.
0.
1.5 divided by 2. V minus U over T. Okay?
Yeah.
Okay. Right, so we get 120 newtons. 120. Okay, this one faster, right? See, already 7.
Yeah.
Oh, what was wrong with the previous one? Okay, so resistor X and Y connected in parallel to shown for an output to determine the current in X. What's the current in X? Okay, you can find where is 6 foot. So you draw a straight line from 6. Right, crosses this path. It's from here, one is from here. The other one is here. Okay, can you see that? So
Yeah.
what is the current in X? X is 0.4. Then the current in Y is 0.5. So far, okay?
Yeah.
Yeah, great. What's the total current in the power supply for PD of 6? What? Okay, so this is a parallel circuit. So we got this X is 0.4, Y is 0.5. What's the question asking? Total current. Now this is a parallel, right? So for parallel, what do you do to the total to find total current? What do you do to find total current for parallel?
One.
You add them, right?
Yeah.
Because I1 equals to
Yeah.
I equal to I1 plus
Yeah.
I2. So 0.4 plus 0.5, we get 0.9. Group. Okay, next one is calculate the energy dissipated in Y only in 10 minutes for the PD of 6. EPT, right? EIV, right?
Yeah.
So at Y, what is the current? 0.5. Correct?
Yeah.
Y is 0.5.
Yeah.
So voltage is 6. So 0.5 times 6 volt. That will give us 3 watts. 3 watts, 10 minutes, 30 seconds, 180, go. Okay, answer right. Alright, next. Question away. Okay, but how to increase the magnitude?
Oh, the force of this wire.
Wait a
Yeah, carrying.
Okay, I'm going to multiply by 10 here.
Oh, course for 10 minutes.
Yeah. 1,800.
Okay.
Okay, next. How to increase the magnitude of the force? So you want to increase the magnitude of force, increase the current. You can increase the current or use a stronger magnet.
Okay. Let's draw an arrow so to show the
Downward.
Why downwards? Why down?
Okay, current, electric current, I mean a magnetic force from north to south, electric current going in. So you use the left hand rule.
Okay.
Right? It should be downwards. Thanks. Okay, section B. If this is quite. Okay, do you want to give it a try? This one.
Wow, what is it?
This one is pressure. This one is light. And the last one is electricity. Which one do you want to try? You try one.
Yeah. Okay.
Yeah. Which one do you want to do?
Son, which pressure?
Pressure.
Light and electricity, is it?
Yeah, light.
Electricity.
Okay. You take a look at this.
Yeah.
Yeah. Okay lah. 4 marks. Okay. Can you see the screen? Okay. So can you give it a try? I'm going to toilet for a while.
Yeah, sure. Okay, let's.
Right, back.
Hello.
Yeah, okay, let's try to do this. Okay, take a look. Okay, find the resistance of X. So R equals to V over I, right? Okay,
Yeah,
so
but you have to use the graph.
yeah, so
I can't really see the graph.
oh sorry. Okay, so the resistance of X change with temperature. Mm, good.
You just minus.
Huh? Oh no, they say the temperature is 30. Right, so we look for 30 degrees Celsius.
Oh.
Yeah. 30 is
Right.
here.
800.
Yeah. Oh, you okay?
Yeah.
Sound very bad. 800.
Okay.
So find the current in the circuit.
Yeah.
So
Alright.
X is 800 ohm.
Yeah.
Now what's the total resistance? 1800 ohm. So we want to find current. I equals V over R.
Yeah.
So it's 12 divided by 1800. Yeah, equals to 6.67 times 10 to the power minus 3. Okay, so that's the first answer.
Yeah.
I go V over R. So second one, third one, find the PD across Y.
That's Ri and
Hmm?
6
P,
point.
uh,
Is it V equals Ri?
yeah, it is. So we just multiply 1000 times this.
Yeah.
Right, we get 6.67 volt.
Yeah.
Alright, formula next. What happens to the current in the circuit when the temperature rises? Now, when the temperature rises, what happens to the resistance?
It decreases.
Yeah, so resistance goes down when the temperature rises.
Yeah.
So when R decrease,
I goes up.
I go up. Okay.
Yeah.
How about the potential difference?
Remain the same.
No, increase.
Huh?
PD across Y.
As temperature rises. Why?
Across Y. PD across Y. Voltage. Because you see this panel goes down, right?
Yeah.
So when this one goes down, what happens to the voltage? You see, at this point of time, this is 6.6.
Yeah.
Right? So this one, there's a certain voltage. These two add together is equals to 12.
Oh, okay.
Yeah. So
Okay.
when the voltage go down, the current go up.
Yeah.
You see, this current go up. So the current go up means this one will also go up.
Yeah.
Right? The voltage increases. So the PD will increase. Right? How about the PD across X?
Decrease.
Hmm?
Decrease.
Yeah, go down. Right, you got it. It says V equal IR.
Yeah.
Okay, what's the function of a fuse and how it works?
It will break if the current state is
So fuse divides that. Alright, if the current is higher, yeah, that's what it is. Right, but you just said everything in a very short way. Right?
Yeah.
Next. Right? Next one. No more already.
Yeah.
Huh? Wait, I thought there's a choice.
We this is question 11. We haven't done the second question.
Yeah.
Still 10, 9 and 10.
9, 10. Oh, yeah. So it's so which one you do? 9 or 10?
I think 9.
9. Okay. 9 looks very short.
Yeah.
Hydraulic jack is used to raise a car. Explain 2 reasons why the force exerted is greater than the force F. Okay, I'm not gonna say. You try. Cannot.
Then explain 2 reasons why the force exerted. Think it's cool.
Oh, I think I also got sore throat.
Huh.
Yeah. The virus passed through the internet, is it?
Pass through a screen.
Pass through screen. You sneeze to the screen, right? Do you sneeze to the screen?
Yeah.
Damn. No, it's because I eat too much chocolate.
Eating a lot of chocolate.
Yeah, I've been eating like since morning.
Huh?
Yeah.
Huh.
As I'm talking, I will eat chocolate, drink the Kit Kat. I got one packet of Kit Kat. When I'm studying, right, I like to have snacks.
Yeah.
Yeah, so I'm eating a lot of chocolate and drinking sugar. Sugar. How's it?
Making two reasons why follows the third on the lifting plate is greater than the force express the lifting plate. Not so sure.
If cannot do how? Do the next one. Can score 1 mark here.
Oh, the whole question.
Yeah.
Oh, yeah. The can. I just don't state and explain two reasons. Yeah, because you know, panic causes maximum speed is constant.
Gases can be compressed. I think part 2 can answer, right?
Yeah.
Okay, so it's got 2 marks there. The pressure on the road, so pressure will force over area.
I think I also can answer.
Yeah, let's analyze, right?
Yeah.
So this one can. This is because gases got a lot of space. This one can. This one can. Pressure to force over area.
Area.
Right? So it's 4 marks. Why fast velocity changes even though it's constant? car drive around a bend. Why the speed changes even though the velocity change? Because velocity, do you know this?
Direction.
Direction, yeah, very good. When you are going around a bend, the changes, so the velocity changes. So you will score 6 marks, not bad.
Yeah.
Okay, can do. Yay. Now let me explain part 1. Why the force exerted is greater than the force F?
Yeah.
Alright. So you see the force F here, there are two things happening here. First, this is moment, right? There's a pivot, so this is a moment. So we call this the anti-clockwise moment. Alright?
Yeah.
So the force is very little because anti-clockwise moment you gotta multiply with the distance. So actually maybe you put like 10 newtons of force, but it's multiplied if this is like 2 meters. So you end up you have 20 Newton meter of moment.
Hmm.
Do you understand?
Not really.
Alright, you know the door thing?
Yeah.
Why door not put here? The hinge is here. Why don't put the doorknob here?
Because you can't open the door.
Yeah, you need more force, right? Here
Yeah.
you need a big force. Here also only need a small force. Why is it further smaller the force? Because you must multiply with distance.
Uh-huh.
This is a small distance. This is a big.
Yeah.
So the moment for when the doorknob is further away, it's big, so you don't have to use a lot of force.
Oh, okay, okay.
Right? So it's the same idea over here. You see, there's a distance. There's a distance over here.
Yeah.
Right? So because of this distance, the force required is very little.
Yeah.
Okay, that's one part. Now the second part, it has got to do with the area. The area here. So on the left, you have a very small area, but on the right, you have a very, very big area. Right? So there's a formula that says FA over A equals to FB over area of B. Now pressure equals to force over area, right?
Yeah.
So the force over here, you see the pressure here, right? The P here is equal to the pressure here, because they're just pushing the water.
So that's why it requires less force.
Yeah, that's why on the left hand side you need less force.
Because the pressure on the left is
The
less.
same. So the pressure is the same.
But the area is less.
The area is big, but this one area is less.
So if the area is less, it requires less force. Is it?
Yeah, over here you require less force. So over on the right hand side, you're gonna need more force.
Okay.
Right hand side here, you need more force.
Yeah.
Okay. Now remember the syringe. This syringe, yeah. So when the area is small, what happens? Can penetrate the skin, right?
When the area of the syringe is
yeah. So can penetrate the skin, right?
Yeah.
Okay. But if an elephant leg, right, the elephant leg stand on you, can it penetrate the skin?
No.
No. Why? Because the area is big.
Yeah.
So basically, bigger area Now this has got to do with the pressure, but I'm trying to say that if the pressure is the same, then the force will be different. The force over here on the left, right, at the piston A
Okay.
is less.
Yeah, okay.
The one over here is more, right? It's roughly the same idea. It's not exactly the same idea. Okay,
Yeah.
but you gotta that's what the formula is talking about.
Yeah.
Pressure equal force variable thing. Okay?
Yeah.
Alright, so maybe we can take a look at the other one. So you can just try to say some stuff here. Maybe you get 1 or 2 marks. And you can get 8 upon 10. That's not too bad.
Yeah.
Okay, next one.
Like traveling from the class into
Okay, find the refractive index. Right, okay. What's happening here is that the light travel at 42 degrees.
Yeah.
And then after that, it didn't go out here horizontal here. Okay, this phenomenon is like because it's nearing total internal reflection. 42 we call it the critical angle. Now you see by right, when light go in like this, right?
Yeah.
It should go out, right? Correct?
Yeah.
Usually it should go out of the glass. But the phenomenon is that at a certain angle, we call it the critical angle.
Yeah.
The light, instead of coming out, it bends to the right.
Bend.
Yeah. So if you increase some more, that means if you were to increase the angle some more, you will get what we call total internal reflection. So you'll go in this way. Is that alright? Okay, let me use human being as an example. Human beings.
Yeah.
You know human?
Yeah.
Do you have an angry friend?
Yeah.
He or she gets triggered very easily. Do you have that?
Yeah.
Triggered means he get mad.
Yeah.
Goes mad very easily, right? So different people have different degrees of tolerance.
Yeah.
Right? So we call that critical. I don't know what I call that. Critical angle. Alright. So if the critical angle is very low, like very low critical angle, right, what happens is that you touch his hand only, he become mad.
Yeah.
Do you have a friend like that?
No lah, not so extreme.
Like you touch, I tell you I have, you know why not?
Really?
Yeah, last time got a commando friend. Commando, because they train a lot, right?
Yeah.
So red commando. And I don't know what kind of nonsense he eats, because I think he eat a lot of those supplements. Right, to make him like stronger and all this stuff.
Yeah.
So he became very angry easily. Right, and then maybe because he keeps running and then they keep shouting vulgarities and whatever stuff, right? Very little thing, he get triggered very easily, right? Example, MRT, you know MRT, a lot of people, right?
Yeah.
Someone accidentally touched him, then he want to punch that fella. You get what I mean?
Yeah.
So that's like the critical angle, right? So on the other hand, there are some people who are always happy.
Yeah.
Right? They don't get mad so easily. In fact, you punch their face, right? They still quite happy sometimes. Right? So the level is very high.
Yeah.
Okay, so what I'm trying to say is that materials also have this kind of thing. Glass. This is glass. So different types of glass also have different levels of triggerness.
Yeah.
So this particular one, right, is at exactly 42 degrees. So what happens at 42 degrees is the light, when it comes in, it will go horizontal here, right? So what if you go more than 42 degrees? So the other one is minutes. So you gotta change to the same time.
Okay.
Now, next, what is the deceleration during the final 10 minutes? Final 10 minutes. So final 10 minutes is here. Decelerates at a constant rate for 10 minutes until it comes to rest. So the formula for acceleration, right? V minus U over T. So the initial is 60, final is 0, right? Over how many seconds? 10 times 60, because it's 10 minutes, right? So we will get 0.1 meter per second squared. Okay? Formula again. Next, what is the braking force during the final 10 minutes? Now, you see this as, we've done this so many times, right?
Yeah.
F equals what?
We
F
got
equals?
MA.
Yeah, MA. So there will be, so we gotta find the mass. 240,000. It's right here. 240,000. So 240,000 times 0.1. So we get 24,000. 24000. Okay, next, the work done to bring the train to rest during the final 10 minutes. So formula for work done?
Work done equals F times distance.
Yeah, so the F is 24,000, right? Now what's the distance it traveled? Before coming to a stop.
60.
So the story is that decelerate constant rate for 10 minutes until you come to rest. Let's say speed time graph.
Yeah.
Let's say speed time graph. Time is 10 minutes. Okay, what's the original speed?
60.
So here's 60. So it went all the way down. Like
Yeah.
that. Okay, so the distance is the area.
So half times speed times.
Time. This one must convert to second.
Times 60 times 10.
Yep. So we will get 18,000.
Okay.
Alright. I mean, yeah, 18,000. So here is times 18,000. Okay, 4.32 times 10 to the power 8 joules. Alright, so that is a massive 379 marks in one question. Plus the previous one, 9 plus 4, 13 marks already. Yeah, that's a lot of marks. Okay, so is it difficult? No, everyone is a different
formula. Everything is formula.
Yeah, so distance, deceleration, F equal MA, work done equal force times distance. You follow the formula, you'll not be wrong.
Yeah.
Okay, don't anyhow think of your own stuff, which you didn't, I'm just saying. Okay, next. Okay, so a pure substance has a melting point of 50. The substance is cooled from 80 until its temperature is 30. Sketch a graph to show how the temperature changes with time as it cools from 80 to 30. Now, we have to take note that the melting point is 50. That means at 50, we will see a straight line, right? Melting point. Right? We'll see a straight line at 50. But the problem is, what time will it be 50?
Yeah.
Okay, we don't know the time. Doesn't matter because they put time here. They put time, but there's no units. Okay, so just make sure that we start at 80, go to 50, do some horizontal thing, and then go to 30 again. Alright.